Okay, in this question regarding permutation and combination, first thing you have to do is to decide whether this is a permutation or combination problem. Okay, look for the keyword here. The keyword here is arrange. Okay, when you arrange them, basically it's a permutation question. Okay, now we are supposed to arrange them in a row. Okay, the two max books are supposed to be together. Okay, if that's the case, then let's combine the two max books into one. So therefore you have one max books, okay, and three history book. Okay, how do you combine these four books together? Basically, how do you arrange them together? Is basically permutation, 4 factorial. Okay, now in each of these permutation, for example, we pick one particular permutation. Let's say I have okay, then I have this history 1, history 2, this history 3. Okay, this is just one of the permutation. Now in this permutation, let's say you have your M1, this is your M2, max book 1, max book 2. So this will give you one permutation. Okay, now but then remember these two books can swap. That means beside this as one combination, I also can generate another permutation whereby M2 is here, M1 is here. This is still the same. H1 is 3-1, is 3-2, is 3-3. That means to say each of the permutation from here you have another one where when you swap the position of the M1 and the M2. That means to say the way you can arrange inside here is actually 2 factorial. It means times 2 factorial. So that will give you 4 times 3 times 2 times 1, and then followed by times 2 times 1. That will give you 4 times 3, 12 times 4 is 48 permutation, 48 way of arranging the 5 book in a row. Okay. Now the max book are not next to each other. Okay. Okay. For this case, what you have to do is you consider all the permutation without restriction first. The mean is 5 factorial. Okay. Then after that, you minus away the permutation where the two books are always together, which is here. Okay. So it's actually 4 factorial times 2 factorial. Okay. So whatever remain from this will be the ways or the number of arrangement where the two mathematics books are not together. Okay. This one is all the various combination. This one include the two book together and the two book not together. Now I minus away where the two book are together. What remain will be the ways or the arrangement whereby the two mathematics books are not next to each other. Okay. Now let's come to this. Chosen. The keyword here is chosen. To select. Okay. After you select, do you make arrangement? This question it's just basically selection. So it's a combination question. So now let's look at the first one. No restriction basically is total number is 9 plus 6 is 15. See how many people you select, 5. So basically that's the answer. Okay. Now this one you work it out the detail. Now what about at least 2 men must be in the team? Okay. Now we can take it in a very direct approach. Means we will select a combination with 2 men. That means 9C2 time. We select 2 from the 9 men, and then the remaining will be 3. Okay, because the total team is 5, so I select 2 and then 3 from the women. Okay, then you have 3 men, then it's 9C 3 times 6C 2, then 4 men, 9C4 times 6C1. You have to add all these combinations together to give you the total. Then you have 5. The maximum can go is a team of 5, so 5 men. So it's 9C 5 times 6C 0. Why 0? Because you select all the team members from the men. Okay, so it's 6C 0. Now, but this is more tedious. Okay, we can have a shorter way whereby we can actually take all the possible combination, which is 15 C5 minus the case where the selection is only involved the women. So it's 9 C0 times 6 C5. That means all women. Okay, all women. And then you also have the case whereby only one man selected. So it's 9C1 times 6C4. Okay. Now, these are all the possible combination. And minus this one, all women. Okay. So these are the one is not included into the requirement. Okay. The requirement is 2 men. So I minus all those combination which doesn't meet this requirement. So whatever remain will be the combination that meet this requirement. So minus away all women in the team and 1 man in the team of 5. Okay, so what remain in this case will be equal to this. This is a very formal way direct. 2 men, 3 men, 4 men, 5 men. But it's more tedious. This one will be less tedious. Okay, you will get the same answer for this.